So for an MVM product overview, like I said, it's an intermediate level variation analysis software, and it utilizes mechanical constraints and PMI. A quick, comparison, again, back down to DVM, you can see these two circles here. One big comparison is that with DVM, we were only working within that geofactor equation-based 3D assembly variation analysis. With this, we're adding back in the Monte Carlo analysis that you're very familiar with when we're looking at the variation analyst package. So we're adding back in the Monte Carlo analysis. And again, it includes all the functionality within DVM, in addition to several other functions. So this is just kind of a slide to show you, hey, we encompass everything that DVM can do, but then we also add in a few things along the side here as well. And we're getting closer and closer to that full variation analyst package. As far as the value proposition of MVM, we have a broad PMI options, broad PMI extraction capability there. We can also extract your assembly constraints, and while we can do that in DVM as well, it's a little bit more of a one-to-one extraction when we're talking about extracting into MVM. We can analyze complex mechanical assemblies, including kinematic ones. It's a scalable solution to 3DCS Variation Analyst. Again, it's just that one pyramid step above Variation Analyst on our complexity pyramid. And it's available to a focused team. So now I'm going to take us through a demo of 3DCS DVM MVM in SolidWorks. So here's the model we're going to be looking at today. This is a mechanical shifter assembly. So it's effectively a 6-part model. We have this gray part here called the base. And then we have this block here that goes onto the base top here. We have this pivot here that goes into that hole on the block there. We have the shifter here, which goes onto the pivot pin there. And then we also have a few links that are going to link onto the side of those parts as we put them together that you'll see. So effectively a 6-part model. And I'll go ahead and click Update Model as we do to load up our 3DCS analysis. And it opened up my 3DCS Model Navigator. Currently this model is completely empty, so I can expand out all of my parts and we'll just see an empty 3DCS Model Navigator. And across the top here you can see that, for those of you familiar with 3DCS Variation Analyst, instead of having a 3DCS and a 3DCS add-ons tab, we just have a 3DCS MVM tab. And inside of that 3DCS MVM tab, we actually have, I believe, close to, not all, but close to all of the buttons that you'd have in the normal 3DCS tab, in addition to these additional buttons that would normally be a part of the 3DCS Mechanical Modeler add-on toolbar. So we're kind of, picking and choosing some stuff from Variation Analyst, some stuff from Mechanical Modeler, and we're combining them together to put together this nice MVM package for you. So we have these buttons across here that are going to be our MVM Mechanical Modeler moves. And then, some other buttons that are probably very familiar to anyone familiar with our Variation Analyst package, or anyone who saw our DVM or any other webinar that we have. So, like I said, at the moment, I have an entirely empty 3DCS model here. So if I select nominal build, 3DCS is going to apply all of my moves. I currently have no moves, so that didn't really do anything for me. I'll separate back out, but really that didn't change anything. So the first thing I'm going to do is I'm going to extract all of my mates that I have in my SolidWorks model. So in SolidWorks, we're using mates. In other programs or other CAD platforms, we're going to call these different things, but the concept's the same. So we have these mates listed down here. And I'm going to go ahead and select this Update Constraints button right here. And this is going to be familiar to anyone who's used our Mechanical Modeler add-on before. It's just the exact same Update Constraints button and the exact same Update Constraints functionality. So I'll click Update Constraints. And then I'll select my assembly. And it'll tell me it was able to create 18 total moves based on the 18 SolidWorks mates that had. And if I go into my list here, we can see that it extracted some mates, or some moves, I guess, from my subassemblies as well. That's another thing that is now available that was not available in DVM, so another capability, down that capability pyramid. We now have more capability in this one, so we can have moves at the subassembly level. And then I'm going to focus more on this outside list of moves, though. And you can see we have all these outside moves, and they pretty much line up with their names and everything one-to-one to all of the mates that I have in my list over here. So now whenever we extract anything from the CAD platform into 3DCS, be it MVM, DVM, VA, we want to make sure that it's functioning as expected. So I'll select nominal build, and okay, my parts did move, so that's good. However, if I'm looking at this, the goal was for these spheres to actually make contact with this face over here and this face over here, kind of on the other side of the face. But it looks like, through the communication chain, SolidWorks kind of told us the wrong command, and our sphere is actually lining up to it on the opposite side of this face. We just want to switch it so that our sphere is on the correct side of its face. So I'll just quickly go into those two moves. So that's just this sphere contact move for the stick over here. And I'll switch it from against to align. Nominal build to make sure that one's working as expected. See that one pushed out now. Now that one's tangent on the other side. You can see that there. And then now I'll switch to the other one as well. So that's going to be the other sphere contact move that I have. So I'll switch that to align as well. And all right, now it looks like my model is going to its correct nominally built position. I can go ahead and nominal build and then deviate, and we can see the model deviate. Only using the allowable floats in each of those moves that I extracted. So obviously I have no tolerances on my model yet because I didn't extract any GD&T yet, but I can see my model deviate a little bit within that allowable float range. So extracting these constraints is really nice, but as far as creating these constraints go, you can also do that within the 3DCS DVM software. I'm going to go ahead and delete this surface contact block to frame constraint right here and just recreate it. Or rather, I'll just deactivate it so that I can just leave that off now. And then I'll head to my moves dialog right here. So you'll recall that you'll recall if you saw our previous episode about DVM, that the only capability that DVM had was that one move option called the feature move. Again, MVM has all the capability of DVM and then some more. So with MVM, we do have that feature move available to you. But in addition to that, we also have the entire suite, or almost the entire suite, of mechanical constraints and joints available to you as well. So this specific one that I have turned off here, is a contact constraint. Sometimes it's difficult for me to always remember what these different names are based on the icons, but that's a contact constraint. So I'll go ahead and select the contact constraint right here and click Add Mechanical. That'll open up a blank constraint dialog here. I'll just call this first move. And this is just going to be a planar contact between my my block face here and then my frame face there. So I'll just select Add Feature on the object side, select the first feature, and then on the target side, there. So now I'm going to move my mounting block down to my frame. I'm not going to deal with these other tabs here. This is pretty much in line, much more similar maybe than doing a step plane move perhaps with how the CAD systems operate, so it might be a little bit more simple for you guys. And then I'll put that back up to be my first move after my fixed frame. And then now if I nominal build, it'll still work. So that's just to show you how simple it is to create these within the tool if you don't already have the mates available to you or you don't trust the mates available to you within your SolidWorks or CAD package. I'm going to go ahead and turn that one I created off and turn the old one back on because I like the name of it.